Okay, great. Well, thank you very much for joining. My name is Eleanor Holton, and I'm going to be telling you about the work that I have been doing with Professor Daniel Nettle at Newcastle University. And we've been looking at why does inequality and deprivation produce high crime and low trust? So I'll start off by talking through the background and theoretical ideas which have motivated this project. I'll then talk you through our methods of empirical testing, our predictions, the analysis and results that we have so far, and then a little bit of a mention of the future directions. The average income of the UK's richest is around 10 times higher than that of the poorest. This is a trend which is replicated across the world's industrialised societies, with income inequality continuing to rise. And this is important because income inequality has negative consequences for a number of health and social problems, including things like increased obesity rates, mental health problems, teenage pregnancy rate, you've got things like educational outcomes, social cohesion, and the list goes on. Of interest in this work, however, is the observed finding that places with higher inequality experience more crime and less trust. Now, these associations may seem intuitive, yet they're non-trivial to explain. How could the distribution of wealth, a population-level variable which isn't naturally perceived by individuals, affect individual-level outcomes such as crime and trust? And this is what Daniel and his colleague Benoit de Courson aim to understand in their recent theoretical publication. So in this work, they simulated populations of interacting agents. All agents aim to increase their resource level, as it is assumed that resource and fitness are related. To do this, they repeatedly selected between one of three actions at each time step. These were exploitation, cooperation, and working alone. So within this model, exploitation was analogous to participating in crime. So it can produce very high payoffs, but it is risky and does leave you open to being caught and punished. The agents could choose to cooperate, which is analogous to participating in legitimate activity. So this is mutually beneficial so long as others in the surrounding population are cooperating too. And then they could choose to work alone. So this is avoiding interactions with others altogether. And this does leave you safe from being exploited against. And the agents were programmed to condition their behaviour based on their current resource level, the behaviour of others, and certain other background parameters. Crucially, they were also subject to a desperation threshold, and this has been adapted from classic risk-sensitive foraging models and is described as a level of resources below which it is disastrous to fall. So this brings in the biologically relevant idea that fitness and resources are related, but non-linearly. So there'll come a point when your resources drop so low to the point where you're unable to sustain survival, function socially, for example, in the case of the risk-sensitive foraging models, reach starvation. So at this point, your fitness will rapidly deplete to zero. Any further hits to your resources from here can't really deplete your fitness much more. So any further hits to your state can't really make a dire state any worse off. Now, using their population simulations with agents subject to the desperation threshold, Daniel Nettle and Benoit de Courson were able to produce some novel outcomes, particularly that each of the three actions, exploitation, cooperation, and working alone, can all be optimal for fitness. It just depends on certain situational variables. So here is an output from the paper here. You can see from the red section on the left-hand side, this shows exploitation. And this shows that exploitation is optimal for fitness when you are below the desperation threshold, regardless of your level of trustworthiness in the surrounding population. So when one's resources are below the desperation threshold, it's always optimal to exploit, regardless of your level of trust. Now, this can be explained by the idea that exploitation is the only action that has the largest payoff that can take you out of desperation and away from the threshold. As I mentioned before, if you are caught and punished, you're only going to be pushed a little bit further down into desperation, which isn't going to reduce your fitness much more. Then you can see the blue area on the top right hand side. So this shows cooperation. And you can see that cooperation is optimal for fitness when you are above the desperation threshold and when your trust in the surrounding population is sufficiently high. And this can be explained by the idea that cooperation produces payoffs as it's mutually beneficial when you trust that others will cooperate as well. And finally, you've got foraging alone, which is shown by the grey section on the bottom. And that shows that actually working alone and avoiding interactions with others can also be optimal when your resources are above the desperation threshold, but when your trust in the surrounding population is low. So if you don't trust that others will cooperate and it's likely that you will be exploited against, it's best to avoid interaction altogether. So this has produced some really novel insights, particularly for the relationship between resource level, fitness, exploitation and trustworthiness. So what we wanted to do in the work that I have been carrying out was empirically test these assumptions within the context of an experimental economic game. So you can see I've popped 2 screenshots from the game on the screen there. And this game has been programmed specifically for this work by Daniel Nettle and his colleague Benoit de Courson. So I'll give you a little bit of information about how this game works. Participants are anonymously recruited in groups of 8. I've been doing this using the participant pool website Prolific. They interact across a number of rounds. In each round, groups of 4 are randomly formed. At the end of the round, they're dissolved, and new groups of 4 are formed in each round. All players begin with 100 points, and the aim of the game is for the players to want to increase their points level as much as possible. To do this, in each round, they select between one of 3 actions. Again, trying to keep very similar to the theoretical model, they can choose between cooperation, stealing, exploitation, and working alone. Within the context of this game, cooperation, if players put 5 points into a joint venture, if it is successful and other people cooperate as well, they receive 10 points in return. However, if the cooperative group is exploited against, the players lose the 5 points they put in. They can choose to steal. So if stealing is successful, the players gain 20 points, so the largest payoff within the game. However, if they're caught and punished, they lose 40 points. The rate of success for stealing is 50-50, so a half. And finally, they could choose to work alone. So choosing to work alone produces no point increase or decrease on average, but you are safe from being exploited against. At the point of deciding their action, players are also asked each round, how well do you trust the other members of your group? And they rate this on a scale of 1 to 10. So in order to really incentivise the participants to want to increase their points level, they're told that the number of points they've accumulated by the last round of the game will be exchanged for a cash bonus at a rate of 2 pence per point. However, we also needed to build in the idea of the desperation threshold. So to do this, players are also told for every round they spend below 100 points, so 100 points is our threshold, their eventual earnings will be slashed by 50 pence. And this happens for each round they spend below the threshold. And this really brings in the idea that if you are below the desperation threshold, you really want to move away as quickly as possible, otherwise it will be detrimental each round. So for example, if you ended on 100 points, this would be converted to 200 pence, but if you spent 4 rounds below the threshold, you would receive no cash bonus. And then some extra information, the participants don't know the energy levels of any of the other players. However, they do have access to their own energy level at all times. And at the end of each round, they're shown the frequencies of the different choices within their interacting group of 4. There is also a small amount of random point fluctuation each round. So this is drawn from a mean of 0, from a normal distribution with a mean of 0 and a standard deviation of 3. And this just brings in the idea that if the players chose to work alone from every round from the first round, they wouldn't stick on 100 points. So the random point fluctuation would move them slightly above or slightly below the desperation threshold. And this is relayed to the participants as the small amounts of energy gains and losses that happen due to staying alive within the game. And finally, the number of rounds is randomly selected per session, and this is drawn randomly from around 8 to 14 rounds. The players aren't aware how many rounds they will be participating in, and this was really important just to stop players kind of, when they're aware they're coming to the last couple of rounds, making throwaway moves, which could affect our results. So, based on the assumptions of the theoretical model, we predicted that in this economic game, individuals whose resources are below the threshold will be more likely to steal than those whose resources are above. Previous experience of being stolen from will reduce trust, and for individuals above the threshold, trust will predict choosing to cooperate over choosing to work alone. So all data was analysed in R using RStudio, and we used general and generalised linear mixed models. These were selected as we have some categorical outcome variables that we needed to analyse, and also we have two sources of non-independence within the data. So firstly, we have the repeated measures of the same participants acting in each of the rounds. And then secondly, we have the data being clustered into 12 individual game sessions of roughly 8. We also took a Bayes factor approach to data analysis, and this was selected for two main reasons. First of all, using Bayes factors, you are able to quantify the evidence in favour of the null hypothesis. And secondly, it allows for optional stopping and peeking at the data without affecting the credibility of the results. Now, in novel research such as this, where we wouldn't be entirely sure of the effect size we were looking at, a power analysis would be fairly inaccurate. So being able to peek at the data during data collection and watch the evolution of the Bayes factor allowed us to maximise our time and budget. So Bayes factors of 3.2 in favour of the predictive model over the null model are taken as substantial evidence, and Bayes factors of over 10 in favour of the predictive model over the null model are taken as strong evidence for our predictions. So we had 84 participants altogether. So this was across 12 sessions. So I said that they were in sessions of 8. However, you do come across things where, especially when running the games online, where participants will drop out halfway through. If this happens, they can be manually advanced by the experimenter throughout the game, which is how we've come to a number of 84. We have 53 females and 27 males. Age range from 18 to 60 with a mean age of 30. All participants live in the UK and 85% of the sample were British or Irish. We had 23 students, 43 in part-time or full-time work and 6 marked as other. So on to the results. So we did find evidence to support our first prediction, revealing that more people do steal when their resources are below the threshold than above. So you can see, marked by the black line down the centre of this graph, that shows the desperation threshold on 100 points. As you move below, the red bars mark proportion of people within that energy level stealing. And you can see that we do change to a higher rate of stealing when below the threshold. This seems to be coming around about 85, so a little bit lower than perhaps we might have predicted, but we did make an open prediction about where the transition to a higher rate of stealing would come. We produced a Bayes factor of greater than 100, indicating evidence of over 100 times stronger in favour of our predictive model over the null model. Our second prediction was also satisfied. So we did find that previous experience of theft reduces trust. So you can see from the red dots, the red points along the bottom, these show people that have previous experience of being stolen from. And the grey show people that do not have previous experience of being stolen from. And you can see that people that do, their trust is consistently lower across the rounds. Again, we produced a Bayes factor of greater than 100, showing very strong evidence for this prediction. And our final prediction, we did find that when above the threshold, social trust predicts decision to cooperate over decision to work alone. So you can see by the bar on the left-hand side, cooperation. When people choose to cooperate, their trust is higher than those who chose to work alone. Again, we produced a Bayes factor of greater than 100, so indicating evidence of over 100 times stronger in favour of our predictive model over our null model. So for this first initial experiment here, we did find really great results and strong support for all three of our predictions. So a little bit of note on future direction. So particularly focusing on this graph that I showed earlier here, we are aware that an output such as this could be produced by other mechanisms. So particularly thinking of things like inequity aversion. So for example, the players may become averse to the fact that they've realised that their points level has dropped below their original endowment of 100 points. And this could be what is motivating the higher rate of stealing due to being averse to inequity. So what we're currently doing is we're in the process of running a second study that aims to tease apart these mechanisms and hopefully provide evidence for the desperation threshold. After that, there's loads of ways that this research could go in. So for example, we would be able to manipulate inequality, punishment severity, and there's loads of different things we can go with. So we're really excited about that. But that's everything I have to say for today. So thank you very much for listening, and I hope you enjoy the rest of the talks. Thank you.